Okay, so we just wrapped up the carbon banking problem, and there was a question about viewing lectures and things like that. So just to to be clear, there are two hour-and-a-half lectures per week. I like to chop them up into 20, 30-minute segments. We just did part 1 of lecture 4. We're now in part 2 of lecture 4. So, and there's 14 weeks, that's 28 lectures, 28 times 3, do the math on the 74, I guess, something like that. Separate little 20-minute chunks of lecture. Now, in terms of when things are due, let me reiterate that. I'm not sure if Peter fully went over it, but the syllabus is the master schedule for when things are due. So, today, we are going to wrap up week 2, because this is Thursday of week 2, and what I'm going to do is launch exam 1. I'm going to make exam 1 available, and you will have until Tuesday of week 3 to complete it. So
the minute before class, or like?
Yeah, the minute before class.
Okay.
Yeah, I mean.
Well, don't wait that
Yeah,
long.
I don't do that because what I'm going to do is I'll grade exam 1 Wednesday. I'll grade exam 1 6 days from now. If you don't have it done by then, then it's really late. So exam 1 will be available for you at the end of this week, which is going to happen in 1 hour from now. Week 2 will end in 1 hour, and week 3 will start at 9:30 on Tuesday morning. And if you don't have exam 1 done by then, it's late. And the same thing is true of summary 1, exam 2. So that's it. Every week there's something due, and you are free to get rocking on it like Thursday at 11, as soon as you walk out the door, and just have it finished on Tuesday before you walk in the door.
And so we just get to exams in Moodle?
Yep, all the exams are right there.
Can you show me?
Yeah, absolutely, yeah.
Are they timed or anything?
Yeah, the exams are timed. I think I've got it set up for 3 hours. And let's just take a look at exam 1. I usually make it pretty easy. It's the last thing you see in week 2. So there we go. 3 hours to take it. Shouldn't take you that long. Well, it might take you that long the first time. And you get two shots at it. Yeah, it's 101. A lot of times this is like, hey, I'm just getting back into college. This is a lot. So, but
Thursday's the 10th.
is
I
the
don't know why the date's wrong in there, but the 10th is Saturday.
okay? I'll fix that then. Thanks.
Mm-hmm.
So here we go. I'll just show you a few of the things. Carbon dioxide. I think you know what that is by now. Peter covered this kind of stuff with you, kilowatts, megajoules, perfect, okay. He covered primary energy, I know that. You'll need to go and look up efficiency of combustion engines. And don't sweat every single problem on the exam. I mean, do your best. We'll talk about it. If you get it wrong the first time, you'll have another shot at it. Most of these are.
Is it okay if we try it and then have questions
Yeah.
and then message you and then retake
You can.
it after?
Yeah, you can. I mean, don't go overboard with that. I mean, prepare for it. But
Yeah.
all of these things are in chapters 1 and 2 of the book. So yeah, they are.
Cool.
So.
Probably 80%, 90% of the information is just going to be taken answers straight out of the book. You just have to find it in those chapters.
It's true.
Then there's going to be a few questions where you're going to have to get out a calculator and some scratch paper and go to town on it.
Yeah. So have your pencil paper ready, and it always happens. Something weird happens where Moodle crashes. It's only 26. I took the exam in 3 minutes. It's a new record.
You did 4.
I probably did prove, the red means I got them all wrong. And so when I see your exams, you're going to get a green, a red, or a yellow. Green means you got 100% on that question. Red is you got it wrong. Some of them, like matching the powers of 10, you might get partial credit for it. And then I go back and grade them all anyway. Another thing to keep in mind with Moodle, it's not very nice in terms of spelling. If you misspell something, it's going to count it wrong. So you might say, oh, I got that right, I know I got it right. Well, I'll go back and grade it, and if it was misspelling, or if you put an extra space, or I don't think it matters about capitalization, but don't stress too much. If your score comes back lower than you think, you probably did, you can only do better than you thought. Your score will never go down, let's put it that way. Does that answer your question?
Yeah.
Okay. Okay.
Well, I guess, is there because I was on there and we had to read that article on there and respond to that.
Which one?
In the discussion,
Oh, yeah, these things, the carbon-free, yeah, and these, yeah, you will just, again, read the forum,
Okay.
respond to it. When it comes grading time at the end of the semester, I can see how many forums you responded to, and if you didn't bother at all, then that's whatever it says on the syllabus, 10 or 15% off your grades. Just go in there. They're not there, like the problem sets, yeah, they're right or wrong.
Okay.
The summaries you're going to get a grade on, but the forum's just hey, it's just bonus, really, in a lot of ways. It's just like a chance to discuss things, especially in an online course, with students that aren't sitting right here right now.
Okay. I'm just,
So-
trying to figure out
Yeah.
what I need to do online. So I
Yeah.
just read the forum for the week.
Yep.
And then,
Read the forum, come to class, realize, hey, what's due this week? Well, there it is, exam 1.
okay.
So there you go. And you saw the syllabus. And then what's due week 3? Summary 1. So let's do summary 1 right now.
and Brad's really good about the beginning of the week or the beginning of class, taking a couple minutes to announce, hey, make sure, this week is a quiz, or this week is a summary or whatever, make sure you're up on this.
Yeah.
He'll remind you.
Yes, I will. Okay, so the summaries, and for now, I'm just gonna make it really simple. I'm just gonna throw a couple things out there. We'll go over it in more detail exactly what I need. But here's what I'd like you to do for summary 1. I'm gonna need at least 300 words. So 300 plus words. I'm going to need 3 plus paragraphs. And the first paragraph just sort of introduces the problem or the paper. What's the paper about? Second paragraph, and you can have more in there if you want. This is just bare bones minimum to get a good grade. What's the paper about? And here's where I'd like you to throw some numbers around. Every one of these papers has some type of scientific basis. So go into the paper and pick up some number. This paper's got a lot of numbers in it. Pick up kind of your favorite technology. If hey, I like solar, I'm going to just go and see, how many watts of energy hit the planet on a regular basis. How many megajoules of energy are hitting my house, whatever. So go in and dig out something quantitative that you haven't dug into before, just like that birthday problem we just did. So dig into numbers and write about it. And put in a quote, challenge yourself.
So basically just support facts and what the paper's about?
Yep.
Numbers.
Exactly. Quote some facts. And then the third one is going to be some opinion. You can wrap it up with an opinion. You can make some kind of policy suggestion, like, hey, if I were the governor of Montana, this would be my energy policy, or hey, if I got to make energy legislation at the federal level, this is whatever, like, just here's your takeaway, here's your little action item, if you will. Or if you think, gosh, this author's like full of it, where'd this guy get his degree, or where did he get his information? You can say that too. Just say, hey, I found other evidence to refute, and that's what peer review is about.
Maybe prediction.
Prediction, sure, exactly, yeah.
What direction is this technology moving?
Prediction, extrapolation, et cetera. So those are kind of your 3 paragraphs. Yeah, Tim.
And number 1,
Yeah.
first paragraph. Not only what's the paper about, who wrote it,
Oh, there we go. Yeah.
and cite your source.
So the
Cite.
summaries are for the forums, or?
The summaries are not for the forums. The summary is going to be separate. So usually what you'll see is a forum kind of at the top, and that's just, if you're having trouble, share it with your classmates, et cetera. Let me get into week 2. Now, the forums are just, well, they're just there. Dive into it, read it, comment on it, move on. The summaries, oh, I am in the right place. You're gonna upload, well, you're gonna upload your summary twice, and there will be a summary forum. And the summary forum is for you to upload when you're done and just get some feedback from your classmates. So, do that. It's the same thing that we professors have to do when we write a paper. We've got to send it up to a journal. Our peers read it, destroy it, send it back in a crumpled wad. Here, fix this, and then you submit it for real, and then then it's out there for the world to read. So that's what the summary form is for. And then when you're done, when you're happy with it, you put it right there. There's 23 people in the course. Nobody's submitted it. Nobody's graded it. I will change that to be a week from today. Yeah.
And on that feedback forum, guys, don't say, looks great.
Oh, there you go.
Give them some honest feedback. If it sucks, tell them it sucks. If it really is great, that's good. Tell them why you like it. Give them some detail. Put a little bit of effort into giving them honest feedback, because when Brad opens it up and starts reading it, he is going to be brutally honest with you, and if it sucks, he's going to tell you it sucks, or your grade will reflect that. So do each other a favor and give each other honest feedback. If you think somebody's way off track, let them know. It's better for them to find out from you than it is, and there's a positive way to do that.
Yeah.
Hey, I think you're missing the point on this.
And if Tim grades it, he'll be really brutally honest, so.
So the summary is, what is it based on? Is it what we've learned over these last chapters?
No, the summary,
Based on that paper.
summary's based on the paper. So glad you asked.
I'm like, what is this summary?
Glad you
paper?
asked. Segue. There you go.
Oh,
So there's the
right
paper.
there. You
There's the
just
paper, yeah.
Okay, so
Yeah.
we're reading a paper and we're all responding to the same paper.
Yep,
Okay,
exactly.
that makes sense.
There you go.
The idea is, of a summary is, I have this really great idea for Brad. I read this really awesome paper. I can say, Brad, read this 20-page paper, you'll really like it.
Yeah.
But you know what, out in the real world, if you tell your boss you have this great idea, you should read this 20-page paper, he's gonna say, you know what, summarize it, tell me what it's about. So you have basically 3 paragraphs to take that 20 pages, pull out what's important, and tell me what's important. Tell Brad what's important in it. So they don't have to waste their time reading it.
Well, yeah, it's almost a 20-page paper, a lot of references. But, okay, so here's another hint.
You wrote it? That's cool.
I did write it, yeah. Another hint on reading these things. You don't have to read every single word in the paper to read the paper. There will be enough information in there, you could write a 3,000-word summary and probably not, I mean, the paper itself is probably 5,000 or 6,000 words. I'm just guessing. So just think about that. You can read you can just read the abstract and fill in that first paragraph and tell me what it's about. I mean, that's the whole point of the abstract is to say what it's about. And then flip through it. Flip through the paper. And a general rule of thumb, and this is something that's always worked for me. It's kind of old school when reading, but this is something I learned a long time ago, just about reading papers quickly. There's this thing called SQ4R, and so the first one is just scan. Scan the paper. Oh, there's some geothermal in there. There's some nuclear. There's some weird picture of a guy breathing exhaust behind a bicycle. There's these really funny looking circles. What's all that about? So the next one is question. What's up with the bicycle behind the car? Why are there funny shaped circles? Why would you have nuclear and geothermal in the same paragraph? Ask yourself a few questions. Then you read it. And read it with those questions in mind. Then you review it. Just review the parts you've already read. And then you recite it. Now this is actually kind of important. So once you've read it and reviewed it, meanwhile you'll be taking notes. You'll be writing. The recite portion, I actually kind of want you to do at the end after you've written your 300 words. Read the paper out loud to yourself, or have your roommate or whoever read it to you. There's going to be some funny sentences in there like, oh, that didn't really sound the way I wanted it to sound when I wrote it. So do that, and then read, review, recite, and then the last one is, this is kind of a cheat, but it's write. And these guys, so writing the summary is actually what you're doing. So then these two kind of go back and forth, the recite and the write. You'll say it out loud, you'll write it, and that's kind of the quickest way. So so a lot of people just start reading the thing word for word. Don't do that. Scan through it first, ask some questions, and that once you've got those questions in mind, you'll dive into it, and those are the answers you'll find when you're reading it. So that's kind of my simplistic way to get through that. So I wrote this paper. I started writing it. I started writing it in 2004. It wasn't published until 2007. It took me a long time to get it published. Publishing in academia is not easy. I submitted it to 2 other journals. I submitted it to one journal called Energy Policy, and I submitted it to another journal called Energy and the Environment. And it was rejected immediately by both journals. They didn't even read it. And I was pretty confused because I put a lot of time into this thing. The Canadian, this paper is getting a lot of hits all of a sudden. There's out there online, there are services for tracking. The Canadian Atomic Energy Commission was going to put this on their website last week. And they called me up and said, we were going to put this up, but you screwed up on your math. I'll show you exactly where it happened. And here's the nice thing about the internet is I can do my own peer review and say, I know exactly what where the error was. They called this out as an error, and technically it is. They said that gasoline has 1/4 the energy density of oil. Well, it doesn't. Gasoline has an energy density of oil they're almost equivalent. Set a gallon of oil on fire, set a gallon of gasoline on fire, about the same amount of heat is going to come out of both of them. The reason that I put gasoline at such a low level is because when you're burning gasoline in a car, only about 25, maybe 30% of it is turned into mechanical energy. You know, the rest is heat and whatnot. And that kind of talks back to that efficiency question that you're going to see on your exam as well. And this is confusing. I mean, I mentioned Steve Running earlier. I meet with Steve maybe once a month or so, and Steve just kind of, looked me in the eye and said, Brad, why don't we just make those coal-fired power plants more efficient? Why are the coal-fired power plants only 35% efficient? I'm like, well, gosh, I can't change the second law of thermodynamics. It's just they're doing their best. That's what it is. So anyway, these papers are reviewed. They're looked at. It's online for the world to see. And anyway, they said, well, you've got this error, and we're not going to publish it. But anyway, that being said,
But really, you don't see it as an error because we're not using it.
It's however you look at it.
It's exactly. It's kind of how you look at it. Right. That's exactly right. And we'll get when we get into lighting systems and things like that, and conservation of energy laws, we'll sort of see how energy flows. So.
Are you going to change it? Or do
You can't change it. I mean, really what I'm doing now, I'm doing my own peer review. This YouTube lecture is going to be up for as long as the internet's alive, and I just changed it. So there you go. Yeah.
How would you describe energy density?
Oh, good question. That's a good question. So the question is, how do I describe energy density? That's a really good question. And there's a few different ways to do it. So let me point you in one direction really quick. I have a favorite figure in Wikipedia that I frequently go to, because there's a couple different ways to do it. Well, there's probably more than a couple, but the two most common ways to do this are, so, and you can use whatever units you like, but the two units used here are, it's megajoules, which is, commonly held unit of energy. Humans, we need 10 megajoules of energy metabolically per day. We use 200 megajoules technologically on average. Megajoules per liter, so this is, let's just look and say, okay, well, where's gasoline? There it is. Gasoline has 35 megajoules per liter. And how back, there's a coffee cup sitting right here for me. There's a liter, and so there's 35 megajoules of energy in that coffee cup. Well, you could also measure it in kilograms. And like a liter is about a kilogram, maybe a little less. You can say, okay, well, gasoline has an energy density of 40 plus megajoules per kilogram. So those are the two separate ways to measure it. One is on a volumetric basis, and that's where you can see, gosh, look at hydrogen. Look how energy dense it is on a mass basis. Well, shoot, why don't we all drive in hydrogen cars? Well, you got to compress it. It's not very energy dense on a volumetric basis. Same thing, the poor batteries are kind of way down here as well. So two different ways to measure energy density. One is joules per unit volume, and they use liters, or joules per unit mass, and they use kilograms. Does that answer the question? And I'll draw a picture too. I'll draw a picture. So the easiest way I think of doing it is like so. This is just going to be 1 cubic meter. 1 cubic meter is, what is it, 1,000 liters? Yeah, 1,000 liters. 1,000 liters. And I don't remember the conversion, but there are a few barrels. A barrel, like a barrel of oil, is a standard unit of measure as well. There are a few of them, and I'm going to say between 5 and 10 barrels of oil per cubic meter. But let's just look at it this way. So, in the hardest thing I had to deal with, and maybe we'll just take a look at this right off the bat. So by now you're familiar with what coal is, oil, natural gas, and they're typically measured per unit volume, per barrel, per liter, et cetera. Coal is usually going to be per ton. So now, but here's the problem. Solar, wind, and hydroelectric it's usually power per unit area. And by now you know that power and energy are different, two different things. And area is not volume, right? So power and energy are two separate things. Area and volume are two separate things. So how do we marry these two together, if you will? Well, in the case of oil, you can just imagine sort of stacking, barrels up inside this cubic meter. A cubic meter is about the size of your refrigerator. So just imagine, packing this thing full of barrels, and then when you're done, you pour in some more oil, and now it's all the way full of. So you got a full cubic meter. The issue I had was with sunlight. This is oil over here, and this is sun over here. But remember, all of this oil got there because the sun was on for so long, doing the photosynthesis and feeding the triceratops and all those guys that then became buried. A cubic meter of photons, I'm just going to write the letter phi for a photon, there's not much in there. And when you actually do the numbers, oil came out to be 35 to 45 gigajoules, and I just converted gigajoules to kilowatt hours, and we'll do a little bit of that here in a second so you get used to it. Solar energy, 1.5 microjoules. And by now you know that giga is 10 to the ninth, and micro is 10 to the minus sixth. So 10 to the ninth, 10 to the minus sixth, 15 orders of magnitude. And all of a sudden you're like, okay, I get that now because I just did the carbon birthday problem. It took a long time for that bank to fill. Okay, so now you're like 20 quadrillion times less energy dense. So, and then I just kind of go through the other ones. How much energy does a human have? How much energy does the wind have, et cetera. So I hope by reading the paper, Kat, you'll sort of get an answer to that question, like how do you define it? I also tried, again, to put a graphic together. This was graphical illustration of what 1/1,000th is, and I did it on an area basis versus a volume basis, so you could kind of see, like, gosh, it's just not very much. Because it's not easy to wrap your head around these numbers. And just for whatever it's worth, I was on the train here coming back, and I met a gentleman, Paul Jensen. I think he was either Danish or Finnish. Anyway, I sent him this paper. He's like, wow, that's a good paper. I think anyone trying to wrap their heads around energy policy and energy crisis or renewables should really take a look at this. He's actually on a coalition to just move this whole airshed between Michigan and Montana away from fossil fuels towards just renewables, and we teach that in our GY 241. So if you stick with the program, we'll show you some of that as well. But anyway, there's a lot here. You might play around with this efficiency equation. That little eta symbol just means efficiency. It's some number between 0 and 1. That's the hot temperature, a cold temperature, and when you divide temperature by temperature, you just get a number. In this case, 0.5. And I also got into a little bit down here, and just to follow up on why this paper was not published in the two journals, Energy and Environment or Energy Policy. I emailed an author by the name of Jared Diamond. I don't know if you've heard of him or not. And Diamond said, well, yeah, Leighton, you're not going to get your green paper published in those journals. They publish about, petroleum. and, fossil fuel energy policy and energy environment. So, they just were interested in this, so it was published in a Canadian journal, International Journal of Green Energy, and anyway, so I also learned a little bit about some of the politics of publication as well, as people hear what they, or read what they want to hear, or hear, anyway.
And the politics and the market are running the same now.
Yeah, it is true. A lot of times you'll see that, politics and dollars are tied together as well. And I've got another paper, I don't know if we'll do it in 101, but it talks about just the socio-economics, or you could even call it socio-political.
Sociopathic.
So sociopathic political economics, but anyway, but my bottom line here is these non-renewable energy sources, they are becoming scarcer. But my point is that they're not really worth fighting over. There's no shortage of renewable energy. There's no shortage of renewable energy technologies to use. It's just a matter of perception, sort of what's truly available and out there. And the whole point of doing this type of education is to show you some of the solutions that other countries have come up with. We'll look at what Germany's up to. We'll look at what England is up to. We'll look at some of the challenges that China and India are facing, and we'll sort of see, what fantastic opportunities there really are for innovation in the United States. We really sit in a very special place and a very special time. So, okay, so that's that paper. Any other questions on the summary? So, it's due. Well, it's due a week from today, and it's late. 12 days from today. You got about 12 days to work on it. More than enough time. So just, if you like reading paper copies, you can, print it out and, read it on the bus, or read it in bed, or read it wherever you like. I gave an interview to Peter Christian and John King. They're the KVGO guys. So Bob Seidenschwartz goes in, and he's the money guy, and so he's talking about what's new in energy, and that looks like some great bathroom reading. So if you want to read in the bathroom, that's fine too. But, yeah. So anyway, they brought this up, and it was kind of fun to check it out. But
So pretty typically every week, like exams due Tuesday, seminars due Thursday.
no, that is not correct. I'm glad you asked. It's okay, my man.
Sorry.
Well, it's okay. And for some reason, it's okay. No, it's all right. And for some reason, and I'll explain it again on Tuesday. I promise. I promise. So let's look at the.
Like the first 8 weeks, literally, we have to work every week.
Well, and a lot of my teaching evaluations say I never could figure out when anything was due in that class. Well, I'll do it one more time.
No, yeah, exactly. I just need to go to here and
Print that out.
Yeah.
Put that in your
Okay.
Put that in your binder.
textbook, and you've got it.
Yeah, and that's it. So I'm going to launch exam 1 in a half hour. And if you don't have it done by week 3, it's late. I'm going to launch summary 1 a week from now. And if it's not,
it's gonna go exam summary.
yeah, and then we're going to throw a problem set in there, week 7, which will be due in week 8. Exam 4 will be launched in week 8. It will be due in week 9.
Cool. So
Summary 3 will be.
the black is what we have.
Yeah.
And then by the next
Yeah.
class, we need to have.
There you go. Summary
That
3.
makes- yeah.
Summary 3 will be launched week 9, it'll be due week 10. Summary 4 launched week 10, due week 11.
That makes sense.
Yeah.
Awesome.
You got it?
Yeah.
All right, we got it.
I think it's just because people are used to seeing dates, like due by this date.
I'm lazy,
You know,
and I teach this,
I like that.
I teach this course every semester, and it's nice for me to know what week it is. It really is, because
Yeah.
you're like, okay, we're,
I just went through Moodle and Energy 241, and I spent about 3 hours just correcting the dates on when stuff is due.
oh, good, because I was gonna ask,
Because Moodle is very,
Kearns to do that.
I think they're very aggressive with Moodle, like,
Thank you.
or actually maybe it was 242 I did it on.
I know.
I'll look.
Okay, thank you. I know, because you'd think the computer would be smart enough, you could just say which week, and then,
Moodle is not an impressive software.
Yeah, I
Well,
know.
especially the first day of school, it was crashed, so like, none
Yeah.
of the teachers could even like show us how to
Yeah.
use it.
Oh, wow.
All right, well, that concludes part 2 of 3. Let's just spend 15 minutes or so doing some conversion. Or wait, we're supposed to end at
Yeah,
10
6
till, aren't we?
minutes.
I guess I'm not used to the new time.
Yeah.
Well, we can do it. I'll start now. If you can stick around for the whole thing, great. If not, it'll be online. But I'm gonna spend 15 minutes on it. So if you need to leave to catch your next class, you're more than welcome to. But let me put this guy in the bank. Camtasia, on the other hand, is very good software. It records the voice, records the video.